So we're going to do a simple review on what we've learned so far this first week of school, right? So far, well, the most recent thing we learned was adding and subtracting integers, right? So do me a favor, copy that down, and we're going to work through them quickly in a bit. I'm going to pause it right here, and I'll pick it up once you guys are done. Yesterday, we learned that adding and subtracting integers is kind of like thinking of money. Anything that's positive is that you have. Anything that's negative or minus sign is that you owe, okay? So it's important that we understand that this -3 actually means that you owe $3. This +5 means that you have $5. So if you owe $3 and you have $5, could you pay them off? Yes. Would you have money left over, or would you still owe them? You'd have money left over. So you have $2 left over. So the answer is +2, okay? Once again, anytime you have a negative sign in front of your number or a minus sign in front of your number, either one means that you owe money, okay? So this -3 means that you owe money, right? This -5 means that you owe money, okay? So this +3 means you have $3, but you owe $5. You cannot completely pay them off. You have $3, you owe $5. They're like, hey, give me my $5. You could give them the 3 that you have, but you're still going to owe them $2. Yay? Okay. Number 3. Oh, yeah, and by the way, if you did the notes yesterday on that yellow sheet, you're supposed to have learned that anytime you have a negative and a minus negative right next to each other, that has to change the plus positive. So when I say a minus and a negative, or this is not a minus and a negative, this is a minus negative. So whenever you have a minus negative, you have to change those to plus plus, plus plus, okay? Even before thinking of money. So anytime you have a minus negative right next to each other, you have to change it to plus plus. And once again, very important that we emphasize right next to each other. These guys are right next to each other. That's why we change them both to plus plus. This is a minus, this is a negative, that's a minus. These are not right next to each other. They have to be right next to each other like this to be able to change them to plus plus. Right here, you're not changing anything. You're thinking of money. So anytime you have a minus negative right next to each other, like down here, there's another one, you have to change them to plus plus first, even before thinking of money. So you might as well change that one down there to a plus plus. Anyway, since we changed this minus minus to a plus plus, let's do number 4. This means what? Do I have 3 or do I owe 3? I owe $3. What does plus plus 5 mean? I have $5. Okay, so I don't even want you to actually do the math yet. This does not mean that you're going to be adding, okay? The -3 means that you owe $3. The plus 5 means that you have $5. You owe 3, you have 5. Could you pay them off? Yes. Do you have money left over? How much? You have 2 left over, so your answer is +2, or just 2, okay? Let's look at this one above. What does this mean? You have $3 or you owe $3? You owe. What does this mean? You have $5 or you owe $5? You owe. So if you owe and you owe, you're going to owe a lot. If you owe somebody $3 and you owe somebody else $5, how much do you owe altogether? You owe 8. So the answer is -8. Right here, you owe $3. -5 also means that you owe $5. So you owe 3 and you owe 5. How much do you owe altogether? You owe 8, -8. So if you're struggling with adding and subtracting, please think about money when you're adding and subtracting integers. And even on your answer, don't just say, oh, the answer is 5. No, you got to think, do I have 5, which would be a +5? Or do I still owe 5, which would be a -5? So on number 6, right here, what does this mean? You owe 3, you have 5, and you have 2. Okay, so if you owe 3 and you have 5, think about that. You owe somebody $3, but you have $5 in your pocket. You can pay them off. You'll actually have money left over, right? How much money will you have left over? Yeah, right here, when you say -3 plus 5, you owe 3 and you have 5, you're going to have 2 left over. So all I did was write my answer down here of these 2. There's my answer, 2. And now I have this blue 2 plus plus 2. I have 2. I have 2 more. How much do I have altogether? 4. That's a total of $4, right? I have $4. That's why that's a +4, not a -4. I hope we get that. Let's try Let me move this out of the way. Whoops. Let's try one of these. This is more fun. Check it out. Jot that down. 3 minus 5 plus 2. 3 minus 5 plus 2. Okay, thinking of money, what does this mean? You have 3 because it's positive 3. The minus 5, what does that mean? You owe 2. I mean, you owe 5. I'm sorry. I was looking at the next one. So you owe 5, and then you have 2, right? So you could say, okay, 3 minus 5. You have 3, you owe 5. You're going to owe 2, and then you owe 2, and you have 2. It's going to be 0. But another thing that you could do, kind of like when we were playing that card game, whenever you had like a red 8 and a black 8, that's like a positive 8 and a negative 8, they eliminate. Because you're adding and subtracting, you could just do these positive ones first and then subtract 5. So positive 3 and positive 2, that's actually a positive 5. And then take away 5 would be 0. So it's up to you, however you want to do it. I'm going to go with 3 minus 5, that's negative 2. And then bring down the plus 2. So negative 2 plus 2 is 0. If I asked you classify that answer and be as specific as possible, what does that answer classify as? Is it a natural number? Whole number. That's right. 0 is the number with the biggest hole in it. Okay? Let's try another one of these. 3 minus 5 minus 2. Or 3 minus a negative 5 minus 2. Even before thinking of money, what do I need to do? Change what? The signs. The minus minus changes to plus plus. Okay? So then I could do 3 plus 5. I have $3. I have $5. How much do I have? Right. If I have 3 in one pocket, 5 in the other, I'm going to have a total of 8. And then I have the minus 2 that comes down. 8 take away 2. Or I have 8 and I owe 2. I'm going to have 6 left over. I hope you guys are getting this. Let's try another. How about that one? Minus 3, minus 5, minus 2. It's a bunch of minuses. Or we could also have said negative 3 minus a negative 5 minus 2. Anybody got an answer? Zero. Excellent. Thank you. Once again, even before thinking of money, if you have a minus minus, you have to change to plus plus. Now you can think of money. I owe $3. I have $5. So right here, when I owe $3 and I have $5, I will have $2 left over. And then you could take this negative 2, bring it down. You have a 2 minus 2. Well, if I have $2 and I owe $2, I'm not going to have anything. So the answer is 0 again. I hope we get that. There will be a lot of questions on the homework assignment today on adding and subtracting integers, right? That's one thing that we learned this week. That was yesterday. What did we learn before that? Well, before that, we talked about comparing numbers with greater than and less than symbols. We also talked about changing fractions to decimals and decimals to percents or percents to decimals and all that good stuff. So let's begin with something pretty simple. If I wanted to change let's say a decimal to a percent, let's write that down somewhere in our notebooks. Decimal to percent. Okay, so somebody give me a decimal, any decimal you want. Let's start with 0 though. 0 point, whatever you want. 0.45. Okay, 0.45. That is a decimal. And if they ask us to change it to a percent, it's actually super easy to do. Okay, now we need to understand the general concept of percent, right? If I said 100%, what does that mean? 100%. The whole thing. I want 100% of that pizza. That means I want the whole pizza, right? I gave 100% effort. That means I gave it all I had, right? 100% means one whole. So the number 1 technically is 100%. Okay? Right here, is this the number 1? No, it's 0. 0.45. That's not even half, right? It's not even half. So to change it to a percent, all you got to do is move the decimal over 2 spots. 1, 2, and your answer will be 45 with a percent, 45%. And that makes total sense, right? Because if I would have said, like, change the number 1 to a percent, 1 to a percent, well, where's the decimal at? If you just are talking about the number 1, it'd be right there. And then you would move it 2 spots, 1, 2, and you'd fill those spots with zeros, so you'd have 100%. So that's why 1 whole is 100%, or 100% is 1 whole. Do you get it? Okay. What if I went backwards? What if I said change the percent to a decimal? Decimal. Okay, so give me any percent. 5%. 5%. Now, if you had 5% of a tank of gas, is that a lot of gas or a little? That's a little. It's hardly anything, right? It's almost zero, right? So think about that, truth. But if to change a decimal to a percent, you moved it 2 spaces that way, to go from a percent back to a decimal, it's just moving it back the other way. So right here, 5% is just taking that decimal and moving it 1 spot, 2 spots, and putting that 0 in there. So once again, it's like if you had a decimal right here and you move it 1 spot, 2 spots, and you fill in the 0 right there with the decimal right here. So that decimal would be 0.05. 5% is practically nothing. It's technically 0.05 as a decimal. So changing percents to decimals or decimals to percents is just merely moving the decimal place over 2 spaces. Yay? Okay. That's good. What about changing a fraction to a decimal? Okay. Give me any fraction you want. Something that's not too crazy, though. 2 over 4, that reduces down to 1/2. So let's do 2 over 5 at least, yeah? 2 over 5. So everybody write down change 2 over 5 to a decimal. It's as easy as this. The top number, the 2, goes inside the division box and it gets divided by 5. So 2/5 is really 2 divided by 5. And you think 5 times what gets you close to 2 without going over? It doesn't work. So that's why we put a decimal here and put a 0 there so it looks like 20. Bless you. And just remember that that decimal that you added right there, you need to move it straight up here. So put that decimal up here. And then you think 5 times what gets you close to 20 without going over? 5 times 4 is exactly 20. 5 times 4 is exactly 20. And when you subtract that, there's no remainder. And voila, we have converted the fraction 2/5 became the decimal 0.4. Okay. Now, this one worked out very nicely. There's some other ones where you add a 0, drop a 0, you get another number, add a 0, drop a 0, get another number. That might happen. But you still end up with the decimal instead of a fraction. So whenever they tell you to change a fraction to a decimal, you're really doing just long division, the top one divided by the bottom one, and you convert it to a decimal. Now, again, if they tell you convert a fraction to a decimal, it's easy. But if they tell you to convert a fraction to a percent, it's kind of like doing this first and then moving it 2 over. Let's take a look at one. Hopefully you guys don't get confused. Oh, I moved the wrong thing there. Convert 3/8 to a percent. Okay, now 3/8 to a percent. Well, first of all, one option, if you're lucky, is to be able to change the denominator to 100 by multiplying it by something, right? So like, let's say this were a 10. If you multiply both top and bottom by 10, it would change to 100 and you end up with per 100, which is a percent. Right here, 8 times something, it will not give you 100, so it's not that easy. What we have to do is change the fraction to a decimal and then the decimal to a percent by moving it 2 places over. So let's first change the 3/8 to a decimal, okay? So we're gonna go 3 divided by 8. We're gonna put a decimal to make it look like 30. And then we could ask ourselves, 8 times what gets us close to 30 without going over? 8 times 4 is 32. That didn't work. 8 times 3 is 24. Subtract, and we will have what left over? 6, thank you. And then from there, we add a 0 and drop a 0, and now it looks like 60. And now we think 8 times what? 8 times what gets us close to 60 without going over? 8 times 7 gets us 56. That's close to 60. And when you subtract 60, take away 56, that is a 4 left over. And once again, we add a 0, drop a 0. Now it looks like 40. 8 times what gets you close to 40 without going over? 8 times 5 is exactly 40. So we know that we're done. So if they ask us to change 3/8 to a decimal, that decimal will be 0.375. Okay, this is a fraction to a decimal. But they didn't ask us to change a fraction to a decimal. They asked us fraction to a percent. So fraction, change to a decimal. Now change it to a percent. How would you do that? Move it 2 spaces over. So your percent is 37.5%, 37.5%. The decimal moved once, moves twice. 37.5%. What do you think? I hope you get that. I could have easily asked you to change a decimal to a fraction. So if I say like 0.31, change that to a fraction, that's really easy to do. Just make a fraction bar, put that 31 up on top, and on the bottom, what would you put? 100. 100. Why is that? Because there's 2 spots, so that's 2 zeros. Or how would you actually read this decimal? If this is the 10th position, this is a 100th position, you would read it as 31 hundredths, which is exactly this, 31 hundredths. And if I asked you to change this to a percent, it's already per 100, so this would be 31% if you changed it to a percent. Anyways, I think I'm going in circles here. Do we get it? How to change fractions to decimals, decimals to percents, percents to decimals, all that good stuff? I hope so. So if we were to have had a quiz today, this is the stuff that we'd be quizzing on. The last thing that we're going to cover today, which is actually the first thing that we talked about early this week, was classifying numbers, right? So just a quick review. When you were a little kid and you were thinking of numbers, what are the first kind of numbers you ever learned? 1, 2, 3, and 1, 2, 3. And you learned that naturally. So, no, you don't have to write this down. Just watch. These are natural numbers. This is a review of what you already have in your notes. Natural numbers. You don't have to write this down. No, you already have it down, right? Yeah, it's already in your notes. Yeah. You grew up a little bit more and you learned about the number 0. I'm just quizzing you guys right here verbally. When you have the number 0, 1, 2, 3, what are those numbers called? They're not natural anymore. What do you call them? Whole numbers. That's right. Whole numbers. Why? Because it has the 0 involved, and the 0 is the one with the biggest hole in it. And then you grew up a little bit more and you realize that you don't just have numbers like 0, 1, 2, 3, but you also have -1, -2, -3, and it's going in both directions, positive and negative. What do we call positive and negative numbers that are nice? Integers. Yep, integers. Okay, so all of these are technically integers. And then you grew up a little bit more and you realize not all numbers are like nice, like 3 or like 1 or like -2 or like -5. Sometimes you end up with decimals or fractions. Okay, decimals or fractions. So if you end up with like a 1/2 or a -1/2 or a decimal 0.75, what do we call those guys? We call those rational numbers. Rational numbers. Okay, and again, ratio means fraction, and fractions are decimals. We just changed a bunch of fractions to decimals and decimals to fractions. So yeah, rational numbers are numbers that are fractions or decimals, but yet they still make sense. Rational means that it makes sense. Irrational, on the other hand, irrational, those are numbers that are crazy. They don't make sense. Now, I mean, what do I mean by don't make sense? I'm talking about a crazy decimal that doesn't repeat, that continues forever, like pi, right? Or like the square root of any non-perfect square number, kind of like the square root of 17. That is irrational. If you do the square root of 17 on a calculator, it'll be a crazy decimal. It doesn't repeat. It goes on forever. That's what we call irrational, right? Oh yeah, by the way, there's one more skill. That skill was to know how to approximate. Like we know that the square root of 17 is a crazy decimal, but you could approximate it and get a más o menos answer with a decimal. So the trick to that is to be able to have a perfect square number list. So how could we get a perfect square number list? You could just create it. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and so on and so on. You guys understand how to make that list, right? Okay. Now, with this list, you know that any of these numbers, when you do the square root of them, you get a nice perfect answer. Like the square root of 81 is what? Square root of 81 is 9. The square root of 4? 2, right? 2 times 2 is 4. The square root of 36? 6. The square root of 25? 5. Square root of 49? 7. So we know that the square root of any of these numbers are perfect answers. Now, if you make this list, you could get a good decimal approximation of any of these irrational square roots. Okay? How's that? Well, 17 is really close to what number out of these? 16. And what is the square root of 16? 4. Now, 17 is a little bit more than 16, which means that our answer has to be a little bit more than 4. So the square root of 17, más o menos, is what? 4.1. It's a little bit more than 4. Cool? So that's another skill that we need to know for the homework today and for the test next week. So if I happen to ask you, what's the square root of 63? Give me a decimal approximation. Well, you'd make this list and you'd be like, 63 is really close to what? 64. What's the square root of 64? 8. So 63 is less than 64. So my answer has to be a little bit less than 8. So what's a little bit less than 8? 7.9. Perfect. What if I said, what's the square root of 31, más o menos? Now, 31, where is it? Is it really close to 25? Is it really close to 36? It's pretty much perfectly in the middle. Not perfectly, but pretty much in the middle. So if this answer, what's the square root of 25? What's the square root of 36? So what would my answer be if it's pretty much in the middle? 5.5. In between 5 and 6, 5.5. So the square root of 31 is about 5.5. Should we do another or are we good? One more? Yes, please. Okay, one more. What's the square root of 82? Square root of 82, más o menos. Approximation. 9.1. That's right, 9.1. Because the square root of 81 is 9. Square root of 82 is a little bit more than the square root of 81. So our answer has to be a little bit more than the answer 9. So it's going to be 9.1. Guys, I apologize for the long review. We are now, well, we should have the skills to open up our Chromebooks and get started on that assignment called 0.2, 0.3, which is classifying and adding and subtracting integers and all that other good stuff, approximating square roots, okay? Get that started. It is homework. It is going to your grade. You could do it at home, but you could do it right now too. And actually, you could take it over and over and over again until you get the best grade.